Hi, and welcome back to Train Signal. We're continuing our advanced features discussion with iSCSI. iSCSI is a very useful technology for enabling shared storage in your environment without the expense of fiber channel or other more expensive storage area network technologies. So we're going to explore the new functionality tied to iSCSI functionality in Windows Server 2012 in this lesson. For those unfamiliar with what iSCSI is all about, basically the general idea we can trace back to the idea of SCSI. And some of you may remember the happy day when you took your IDE hard drives out of your servers and installed a SCSI controller to run your SCSI disks. It was a new, improved kind of storage technology for disks that you could put inside of your computer. What we now call direct attached storage, just to have some way to be able to refer to the old school way of putting hard drives physically inside of server computers. Can you imagine anything so primitive? Anyway, that being said, that same idea, being able to talk to SCSI devices in a computer, is now being deployed to be able to communicate with storage of one form or another outside of a computer. iSCSI, SCSI over the network, is what we're essentially talking about. We're able to use the same kinds of commands that are used to talk to a SCSI hard drive, but instead of targeting a local disk in the local computer, we're going to send that message across a TCP/IP network and connect to what's referred to as an iSCSI target. That iSCSI target is a device. It might be a Microsoft Windows Server 2012 server. It might be some other third-party device that supports iSCSI. iSCSI is an industry standard technology. It's a standards-compliant implementation that Microsoft provides for it. We're going to use our iSCSI initiator, the client component of this, to reach out to that iSCSI target and build a connection. If we can do that, we can treat storage on the other side of the network, indeed potentially on the other side of the world, as if it were a physical disk in the computer that's running my iSCSI initiator software. It's a very nifty concept. Important things that you want to know about the rollout of this feature for Windows Server 2012 is that Server 2012 can now be an iSCSI target server. That's neat. In the past we needed third-party software for that, or we needed to download something available from Microsoft to be able to turn on that feature. For the first time, Microsoft has embedded the iSCSI target functionality in one of their server OS releases. Server 2012 is the first to do that. The iSCSI initiator has been out for a couple of releases, so that's not new functionality in and of itself, but certainly it's a good time to be able to revisit that functionality, seeing how we can now do the whole front end and back end of this process within the Microsoft family of products. So let's take a look at configuring a target server, and then we'll turn around and configure the flip side of this, which is the iSCSI initiator. The iSCSI initiator is the component that connects to the target and retrieves information. So we'll go one step at a time. Let's do the target server first. I'm going to flip over to our server environment and we'll demonstrate that functionality. So here I am on Server 1. Server 1 is my standard Windows Server 2012 server we've been working with all through these series of lessons. What I want to do is I want to be able to illustrate the ability of iSCSI to be able to reach out and touch storage in some other location. First, let's take a look at what the physical storage is like currently on this server. I'm going to go to Server Manager. From Server Manager, I'm going to get to the Computer Management Utility. That used to be fairly easily accomplished by right-clicking the computer icon and going to the Manage command. That, of course, now brings us to Server Manager, so I might as well just go there first. Tools menu does contain my good friend Computer Management. It's been around since Windows 2000. Inside of which the tool is relevant for viewing what's happening as we work with our disks, a tool called Disk Management. And there it is, sitting serenely inside of Computer Management. At the moment, I see a fairly ordinary hard drive configuration. I've got what appears to be a local disk, disk 0. It's 127 gigs. We're using 127 gigs of it for our system partition. We've got a reserve partition there. Maybe that's for, BitLocker or things of that sort. DVD drive. So 2 disks. Disk 0, local hard disk. CD-ROM 0, CD drive. So far so good. Maybe I've reached a point where I'm running out of storage in drive C. And maybe I don't have room in the chassis of this server to add another physical disk. Imagine that we're at whatever the physical limit is for the chassis of this particular server computer. I need more storage available to this server, but I don't have room to physically add the drive. Do I really want to start removing older, smaller drives, copying data over to new, larger disks, installing those? That sounds like a lot of work. It sounds like a lot of downtime. Is there a better way to do it? Turns out there is. We can roll out iSCSI. So we need two pieces. We need an iSCSI initiator on this side, and I need an iSCSI target somewhere out of my network that I can connect to. So let me flip over to server 2, and we'll turn on the iSCSI target feature to be able to give us something to be able to aim at. So here I am on server 2. We're getting ready to install the iSCSI target server feature on this box. Let me jump over to Server Manager. And because I'm a patient administrator, I wait for the little inventorying process to take place with the little scroll bar up here. Once that's done, now I can go ahead and click Add Roles and Features. I'm going to click Next. Wants to know, do I want to install a role or feature-based component? I do. Onto which server? This one. Where is it? This particular feature resides inside of the broad collection of file and storage services features. File and storage services is a system role within which we've got a file on iSCSI services role service, one component of which, there it is, the iSCSI target server. That's going to turn on the file server role. That's fine. I'm going to click Next. No particular additional features I want to add here, although for later discussion it's worth pointing out that there is an option here that may be valid for some of your organizations, something called MPIO, multipath I/O, for when I want to be able to connect to a SAN environment using two network adapter cards through maybe two different switches to hit two different connection points into my storage environment. That's called MPIO, multipath I/O. In a large iSCSI environment, you might choose to deploy an ISNS server. It's a little bit like having a DNS server for iSCSI. I'll address that idea a smidge in a bit here. In this case, we need neither of those to be able to roll out a basic iSCSI implementation. So I'm going to skip past that and click Install. And it's going to take a moment here to be able to finish that installation. This is going to take a minute. Let me speed this up. Hang on a second. And there we go. We've successfully installed that feature. I'm going to click Close. And the logical thing to do would be to go to the Tools menu and go look for something there to be able to click on to be able to do iSCSI. We see something called iSCSI Initiator. Is that it? No, interestingly. To be able to configure the iSCSI target server, we go in a different direction. This command, iSCSI Initiator, is to be able to be the client in a connection to a iSCSI target server where I want to go gather data from. To actually configure this computer as an iSCSI target server, there is no MMC snap-in of the type that we've seen in earlier versions of the OS. What we're going to do instead is come over here, all the way over here on the left, there's a File and Storage Services node, much in the same way that we saw when we installed IPAM. If you were there, if you attended our IPAM lesson, you can go visit that idea and see that deployed. Here, I can see that I've got an iSCSI configuration environment right here that I can configure through this interface. So the starting point of an iSCSI environment is storage. I've got physical storage on this server. I want to be able to make it available to the other server, again via this nifty iSCSI connection that we're setting up. So I need to identify how much storage do I want to make available. To be able to make that storage available, I'm going to launch the new SCSI virtual disk wizard here, or I could do the same thing by going to the Tasks menu, creating a new iSCSI virtual disk there. Either way, I get a choice of from where on my current computer, I'm now on server 2, that I want to get that data from. In this case, I've got a local drive C that's got plenty of available hard drive space on it. Let me carve out a, 20 gigabyte chunk of space from this area to be able to make available to server 1. It wants to know what's the name of this virtual disk. Not a crazy idea to name the virtual disk for the purpose that you're making it available. This is going to be for the new application storage on server 1. The production department needs more storage, so this is for production application on server 1. We're configuring the storage on server 2. Server 1 has the application. I might supply a description there if I chose to. I want to be able to make sure that later on when I come back to look at these disks, I know which ones are used for which purposes. I click Next. I specify how much space I want to set aside. 20 gigs was what I had suggested. Of course, that could go all the way up into the terabytes range. And it now wants to assign this virtual disk to something called an iSCSI target. Now, we haven't defined targets as of yet exactly, but we're going to create one here. An iSCSI target is a logical place for an incoming client connection from an iSCSI initiator to connect into. And at the moment, I haven't defined any of them, so I have the option to create a new one. I could potentially use an existing iSCSI target if I felt like it. I'm going to click Next. We want a name for that target. The target is going to be able to define access for a particular incoming server. We're going to calibrate it specifically to allow in just certain connections. So it's very logical to name the target in a way that reflects who it is who's going to be coming in via this iSCSI target. So in this case, we've got server 1 connecting in with its production application. So I might call it something like production app target, something along those lines, something that will make it perfectly clear to me and anybody else who cares to know exactly what it's for. Again, I could supply a description to give myself some idea of what it is that I did this for. The next question is, which access servers are we expecting? Who are we expecting to come visit to try to connect in to this target? As I click Add, I get a dialog box to specify who it is who I anticipate is coming in. And I can specify that one of a variety of ways. The most common is to specify a specific value that makes it perfectly clear who's connecting in. I could alternatively use an initiator cache, which is to say the list of other connections that have come in. If a connection came in from some server, I might see more connections come in at a later point. I want to specify access for them again. We've also got access for something called a query initiator for newer computers. That's a Server 2012, a Windows 8 feature. In this case, we're going to do an IQN, or commonly you might see an IP address. If I know the IP address of the computer connecting in, that's probably the simplest approach. I could also use the DNS name of the computer. I could use the MAC address if I'm feeling terribly creative. Let's do a simple one. Let's use an IP address. In this case, we know that server 1 connects in with an IP address of 172.18.38.1. Clicking OK, we've now established the iSCSI initiator that we're anticipating coming in and connecting to this virtual disk that we just got done building. We have an option if we choose to enable authentication. And we can do that in one of two different directions. The orthodox way to be able to do this kind of authentication is for the client, the iSCSI initiator, to prove to the iSCSI target, the server, that it is who it says it is. In other words, the server should not allow access to the storage unless the iSCSI initiator can prove that they are who they say they are. That's accomplished through the Challenge Handshake Authentication Protocol, or CHAP. And I can specify a username and a password to be able to secure that connection. Interestingly, I have the additional option, if I would like it, to do reverse CHAP, to cause the server to authenticate itself to the client. The client says, hey, server, I want to make sure that you are who I think you are before I start requesting data from you, to make sure that you're not some sort of a hacker impersonating the server I mean to get data from. So, CHAP and reverse CHAP are our two authentication options operating in opposite directions from each other. So that's the idea there. In this case, I'm going to enable neither of them and click Next. It's now summarizing all the details that I've supplied so far. That looks great to my eyes. I'm going to click Create. The wizard completes the process of building the disk, associating it with the iSCSI target that we just described. We're good to go. I'm going to click Close. And we can see here I've got an iSCSI virtual disk defined up top. Production app server1.vhd. Some of you might recognize that file extension as the same one that Hyper-V uses internally. It's a 20 gigabyte chunk of space. It's expecting an incoming request from an initiator using IP address 172.18.38.1. We can see that it's deploying using a target name of production app target. And there's that target down here. Production app target is deployed here on server 2. It is using an IQN, an iSCSI qualified name. Components of the iSCSI architecture describe each other using these great big long ugly pieces of data. The intent here is to provide some description of exactly what we're referring to and make those identifiers unique so that no two different components of our system have the same name. The way that's accomplished is by building this great big long ugly piece of data that includes initially this thing called a prefix. The prefix starts at the beginning of the IQN and goes to about the colon that you see here right before NYC. And all of your Microsoft iSCSI elements will all start with the same prefix. IQN, that's iSCSI qualified name, .1991-05.com.Microsoft. Well, you see, if we read it backwards, we get Microsoft.com.1991-05.IQN. It's almost like a web address of a sort, except we're not trying to describe an actual location on the internet. What we're trying to do is create a unique identifier. Well, in a number of circumstances in the IT world, we'll build unique identifiers by naming the company that configured that item, because that narrows the field to just the organization that has that particular domain, and that's your organization. Now, of course, domain names can shift from one company to another, so it's reasonable to prefix that there with a date during which you owned control of that particular address space. And Microsoft certainly had control of the Microsoft.com domain in May of 1991. Interesting little bit of trivia, May of 1991 was also the date in which Microsoft formally broke their relationship with IBM as they were in the process of developing the OS/2 operating system, OS/2 NT, and Microsoft decided to go their own route with what they eventually developed into Windows NT 3.1. So perhaps there's something in the auspiciousness of the launch of the Windows NT project there that caused the Microsoft engineers to encode that in the IQN. Anyway, that's the prefix. What follows is stuff that makes it unique within Microsoft iSCSI type configuration. NYC-server2, well, that's this server. Prod app target, you may recall that's the name of the target that we created. -target, a suffix that makes it clear that it is a target. The software couldn't have anticipated that I would include the word target in my target name. Okay, very good. So we have an iSCSI target. That iSCSI target makes available an iSCSI virtual disk. Now all we need to do is to connect to it from the other side. Let me jump back over to server 1 and we'll connect in. So here I am back on server 1. I want to be able to gain access to this nifty new piece of storage over there on server 2, but I don't see it just at the moment. I'm looking at computer management. It's not there. If I right click and scan disks, it's still not going to find it because I have not told server 1 to go connect to that set of storage out there on server 2. So my technique is to use my iSCSI initiator. That's again launchable from Server Manager. First time I do, it warns me that the iSCSI service isn't up and running yet. Do I want to launch it? Yes, of course I do. If I click yes, it will start it now, and it'll set it to auto start. Each time this server starts up, it will start the iSCSI service. And there is the iSCSI initiator, in which we're able to start the process of building a connection to our destination and having access to the resources that we need. So, we need to identify where we're going and which particular iSCSI target we want to connect to when we get there. We can do those two things at the same time by utilizing a feature called Quick Connect. If I use the targets screen, identify the name of the server that I want to connect to, or its IP address, which in this case is NYC server 2. If I click Quick Connect, it's going to both connect to that server, inventory the list of targets that it finds there, and connect to the one and only one at the moment target in that location. Let me quick connect to that location. It says, hey, I see a target. And you might recognize that's the same IQN we just saw a moment ago. IQN.1991-05.com.Microsoft, NYC server 2, prod app target, same guy. So we've successfully connected to that target. I'm going to click done here. And that's all I technically need to do for this simple configuration. I'll show you some more sophisticated configuration in here in a moment. But for the moment, let me go ahead and jump back to disk management on this computer. And let's note that we now see a disk 1 that appeared kind of all out of the blue. Got a little thought balloon that tells me this is an offline disk. We have not yet told this server to bring that disk into an active state, so we'll do so by right-clicking the disk description area over here on the left and saying I want to bring it online. That disk is now online, but as of yet it is still a uninitialized disk. The operating system has not put its little stamp of approval on that disk to say this is mine. It's a way for this server to be able to recognize that disk if I detach it and reattach it later. In this case, it's a virtual disk, so not a lot of chance of that. But let me go ahead and initialize that disk. It wants to know what sort of a strategy I want to use to describe the partition structure inside of it. The classic approach is the MBR, the master boot record approach. GPT's, GUI partition tables, or GUID partition tables, are a newer approach that allows a larger number of partitions in the same disk. So let me OK this. And I now see that I have access to a basic disk that is online. And as far as anybody would tell, that is a disk that is physically on this computer. And here's the important thing. The computer thinks of it as a disk on this computer. And what that means is the operating system is going to write to that disk as if it's a disk. It's going to issue what are called block level commands. It's going to issue commands to this disk to move certain blocks of data from this address to that address, and take this block of data and rearrange it with that block of data and delete that block of data. And that all happens in a way that is now going to be translated into network communication. It's going to travel across the wire to server 2, where it's going to then be implemented on storage that's at that location. Contrast that against what's sometimes called NAS, Network Attached Storage Devices. I can give a Windows Server access to a NAS, a Network Attached Storage Gadget, but the server doesn't view that as a disk, it views it as another server. It looks like a file server to this Windows computer, and it's able to talk to it using things like SMB, the Server Message Block Protocol. Here, we're able to treat this chunk of storage like it's a drive. We're using block level storage instead of file level storage. Now, that being said, I can use this like I can use any other drive. If I need to be able to create a chunk of space to be able to use from that available pool of storage, I can create a volume, much like I would do, exactly like I would do on a physical disk. I'm going to click Next. How much space do I want to use? Perhaps all of it. What drive letter do I want to use? E is the next one available. That'll be fine, or I could choose my own. We do also have the option that we've had going back to Windows 2000 to mount this storage in a particular folder location, and that's kind of an interesting trick. I can maybe envision a scenario where the application that we're creating this storage for writes data into a particular folder on the computer. And the challenge there is that folder is on drive C that's running out of room. Well, I can now make that folder be mounted on disk 1. I can say that I want the storage space in disk 1 to be accessible through drive C in a particular folder in that location. C/program file / something, application data, and all of a sudden, this chunk of storage space won't have a drive letter of its own. It's going to share space in the C drive, if you want to think of it that way. I get to choose a file system, of course. NTFS is the logical choice. There we go. It's letting me know that I didn't assign a drive letter. That was on purpose. Actually, I think I misread that dialog box. I wonder why it didn't like the name. Let me change the drive letter and path. Yep, somehow it didn't like my attempt to assign the mount point to that. Let me take another whack at it. Okay, it seemed to like it that time. So, that being said, I can now go browse into my C drive. And in the C drive, I've got a folder that's called App Data, but if you look closely, that's not a picture of a folder. That's a picture of a disk with a little shortcut icon on it. And sure enough, there's a chunk of 20 gigabytes worth of storage accessible to that container that is in fact not truly a folder on that drive at all. It is most correctly understood as a chunk of storage space over there on server 2. What a neat trick. That's cool. Let's do that again. I want to take a slightly different approach to it. What if I'm worried that the IP address of this computer might change at some point? Is there some other descriptor I can use of server 1 in a way where I can feel confident that the identifier won't change even if the IP address of the computer changes for some reason? From time to time we'll re-provision the computer's IP address scheme to be able to fit with an expanding network or a shrinking network or that sort of thing, reallocating resources. So how do I handle that? What we can do is in the iSCSI initiator, we can go to the configuration tab, and here's another IQN. This IQN has the standard Microsoft IQN prefix iqn.1991-05.com.microsoft : but look at the back half of it. That piece of text should look familiar to you. That's the DNS style FQDN, fully qualified domain name, of this computer. And that's not going to change anytime soon unless we rename the computer. It's certainly more likely that we'll change the IP address from time to time than to rename the computer proper. So, why is that important? You might recall that IQN was one of the other options that I could have chosen when I created the access mechanism for my iSCSI target. When I created the target, I could choose IP address, I could use DNS name, I could use MAC address if I was feeling terribly clever, or I could use IQN. And this is the IQN for this server. If I specify this string, I have to type it carefully, it's a lot of text. If I type it carefully and correctly over on server 2, I can build a chunk of storage that's only going to be accessible to this particular computer. Even if somebody else out there were to suddenly reconfigure the computer with the IP address that this computer has and try to connect into that iSCSI target, that connection would fail because that target would be now looking for this piece of text, this IQN, instead of looking for a connection from a specific IP address. Interesting idea. So we can do a number of interesting things with iSCSI in this configuration. The obvious one is just to make storage available for applications, things of that sort. I can add storage to a server that's running out of room and extend its life in that sense. We'll see that iSCSI becomes important in clustering sorts of scenarios. We'll discuss that in a later lesson. One other interesting solution available by way of iSCSI functionality is something called diskless servers. If I can put arbitrary storage on some other server, it's not crazy to imagine that I can put all my storage for a server on some other server. Now you're thinking, well, wait a minute, is it possible to have a server that boots with no disks in it at all? Windows has no problem with that, as long as it's got somewhere that it can go to be able to boot from. And as it turns out, modern network adapter cards for server computers can be configured to do a diskless boot, where the server uses its network adapter card to connect to storage over on some other server, and in that storage on that other server is the operating system that we want to boot. What an interesting trick. So I can deploy diskless servers with the help of iSCSI functionality. So we've seen how to configure iSCSI target servers. We know what that's all about. We've seen how iSCSI initiators work. We're able to reach out using the Quick Connect feature in the simplest of scenarios, or we can manually configure if we want to set up elaborate sorts of scenarios. And one of those elaborate scenarios might include something like high availability scenarios. If I've got a need to connect from a client to a server, I now run the interesting risk of what happens if that network connection goes down. What happens if there's a problem in that connection? And there's a couple of ways to be able to help deal with that situation. One called MCS, one called MPIO. MPIO is in general, the preferred approach. Most organizations that are trying to deploy a highly available iSCSI solution are going to lean towards MPIO, in which we're going to use multiple network adapter cards in the same computer and use those NICs to connect to the same iSCSI target. The idea being that if one of the connections fails, if one of the NICs goes offline, we're still able to connect over the other NIC. Neat idea. In many cases, those multiple NICs are in turn connected to multiple switches. We might use dedicated devices for that purpose called host bus adapters, HBAs. Those host bus adapters connect to multiple switches, and those switches in turn connect to our storage environment, so that I've got more than one path from my source to my destination. I've got two NICs. If one NIC fails, the other one's able to take up the slack. I've got two switches, so if one switch fails, the other one is able to handle the connections, and so on. The other approach is called MCS. MCS gets used principally in cases where MPIO is not a possibility. MPIO uses a technology referred to as a DSM, a device-specific module, a piece of software to be able to describe exactly how to talk to certain kinds of gadgets. In the event that I'm trying to connect to a device for which I don't have a DSM, it doesn't support MPIO, MCS is my next best approach, in which I'll build multiple TCP sessions over my available connections. I'm not using multiple pathing in the traditional sense, but I do have multiple simultaneous TCP connections. Some of you may have seen the scenario where you're connected to a web server, you're downloading a piece of software you want to install, and the application download halts in the middle of the download, something with the connection failed. What would have been neat is if you had two connections open up to that same server at the same time, so that when one failed, you can continue getting data over the other connection while you try to reestablish the first one. Neat idea. That way the whole connection doesn't fail altogether. That's the same idea here. We're deploying multiple TCP sessions. This is what's referred to as, again, multiple connection session functionality. Neat trick. To deploy these, we're going to go back to our iSCSI configuration window, our iSCSI initiator. And in the iSCSI initiator, we're going to go to this area here labeled Discovery. And in the Discovery area, I'm able to describe the places that I want to be able to connect to. I'm going to go discover a portal for iSCSI work. It wants to know what's the IP address that I want to go connect to. I would supply that if I was going to go illustrate this, and click Advanced. It wants to know which IP address am I connecting from, which IP address am I connecting to. I can build multiple connections of this sort. I can now see multiple potential locations out there. So that's multiple target servers. Separately, for any given target, I can highlight the target that I want to connect to, pull up the properties of that connection, and identify additional sessions. This is for MCS, to be able to identify multiple connections to that same server. In which case, once again, I would specify where I'm connecting from, where I'm connecting to. If I want to do MPIO, multipath IO, I need this checkbox. If I don't, I'm doing MCS by default. So high availability is a very important solution. If we're going to be doing iSCSI, it's probably very important to design a thoughtfully developed high availability approach, so as to make sure that we, as we take our storage and put it at some distance from the server that processes that data, that we're able to do so in a way that is resilient, where if there are surprises in the network, and there will always be surprises in the network, that we are nonetheless able to handle that wisely and well. So that brings us to the end of the high availability section of the iSCSI lesson. Indeed, the entirety of the iSCSI lesson is at its finish. I look forward to sharing more information with you in the next lesson.